All right, so here's a problem. We're going to work this. We want to find the absolute maximum moment in this beam. And we got 3 loads. So you might remember from our discussion the other day is if we have 3 loads, we have to check how many cases?
3 cases.
3 cases. And the first step in finding the absolute maximum moment is we need to take our set of loads and resolve them into a resultant force and a location. So the resultant force will be easy. It's just the sum of those. So I know it's 2 kips plus 1.5 kips plus 1 kip. So it looks like the resultant force is 4.5 kips. Now where does it land in here? Where would it create the equivalent moment in reactions as this set? So what you have to do first is find what kind of moment the original set will create and make sure it's the same using the resultant force. So what I'm going to do is pick a point. I think I'll just pick the front point. And I'll sum moments of this set about the front axis and find out excuse me, what that value is, and then make sure it's equivalent with the resultant force. So I'll just draw that out so you can see it. So here's the 2 kip force, and I know that's hard to see. We already talked about that. So that's 8 feet back to the 1.5 kip force, and then 4 feet back to the 1 kip force. So what's the moment about this point right here? Yeah, I'm not going to use right-hand rule. I guess I will. I've done it all the time. I'll continue. So this will all create negative moment. And the first one would be 1.5 kips times 8 feet. And then minus 1 kip times 12 feet. So that's 24, right? Negative 24 kip feet. Is that what you guys got? 1.5 times 8 is 12. 12 plus 12 is 24. Is that right?
Yes.
So that's the moment created about that. Now that same moment, if I were to do it about that same point, what's the moment for the resultant force, which is 4.5 kips, at some distance, say x1. So what distance x1 will give me the same moment? So when I do the same thing there, if I sum moments about that point, it's not equal to 0. This is not equilibrium. I made a mistake. So I would have, again, negative 4.5 kips times x1. So these two things are equal. So therefore, x1 is going to be 24 divided by 4.5. What's that? 5.33? So now I know where the equivalent force is in that setup. Now remember the technique we talked about. You're going to take the resultant force, we now know its position, and in turn we're going to balance that force with each of the 3 forces around the center line of the structure. Okay? So case 1, so I'm going to look at the structure. Here it is. I'm going to imagine the center line. And I'm going to now start with the 2 kip force. So what's the difference? What's the distance between the 2 kip force and the equivalent force? It looks like it's 5.33. So I'm going to cut that in half and balance it. So that means that I'll have my 2 kip force here. And what's half of that?
2.67.
So we'll have 2.67 feet here, and then 2.67 feet back. We hit the equivalent force. Okay? Now where do the other ones fall? So where's the 1.5? That's 8 feet back.
That's 2.67.
Yeah, so it's from here to here is 5.33, so the remaining distance will be 2.67. And that will land here, which is 1.5 kips. And I know this is not to scale, but then 4 feet back farther would be the 1 kip force. So that's the position. And the place we're looking for is right under the force that we're balancing. So I'll have a reaction at AY, and I'll have a reaction at BY. And we're trying to find the moment right there. So that means I'm going to cut the structure here and look at the moment. So if I cut the structure here, I'll just imagine a cut. Do we want to work the left side or the right side?
Left side.
Probably the left side. So if we do that, I'm going to need the reaction at A. So how do I find the reaction at A? Yeah, we're going to sum moments at B. This time we are going to apply equilibrium. Now, when you do the summing, when you do look at the statics of the structure, you can use either the original load system or the equivalent, not both. And of course, the equivalent system is going to be the easier because it's just one force. So I'm going to sum moments about B and only consider the equivalent system. So about B with right-hand rule, that 4.5 is going to create a positive moment. What's the distance from B to that? Well, the distance to the center line is 15 feet, or half, and then we come back away from that 2.67 feet, right? So that should be, what, 12.33? And then I'll have my reaction at A, which creates negative moment, times a moment arm of the total length, which is 30. So what is AY? Like 2.5, I'm guessing.
1.85.
Oh, that's close enough. 1.85? Anybody else get that? Yes. So now what can I do? I can actually cut the structure at that point. I know my reaction AY is 1.85 kips, and I'm looking for the moment there. What is that? What is this piece of the beam? What's this distance? Which again is the distance from A to the center line is half, or 15 feet, and then I come away 2.67. So again, this is going to be 12.33 feet.
Question.
Yeah.
Why are we taking the moment about that point and not the center line?
You might remember back in class we had that long derivation.
Yeah.
It was based on the fact that you're trying to find the moment under the force that you're balancing with the reaction, the resultant.
Okay. So
And we're trying to the derivation involved maximizing the moment under this point, and at what position would that maximize? And we found out it was when it was equidistant from the center line with the resultant force. So when we do the other ones, when we balance the resultant with this one, we'll look under that force. And we balance the resultant with the last force, we'll look under that one. So that'll tell us the location. And statics will tell us the value.
Okay.
So right now the location of this moment is 12.33 feet from A. That's the location. What's the value? Well, all you have to do to find the value is what? Take the moment, right? And that's a pretty easy thing to do. We'll just sum the moments at the cut, and that'll have to be an equilibrium. And what do we have? Well, the moment's positive, M. The moment created by the the negative, the 1.85 is negative, and then the distance is 12.33 feet. So what's the moment equal to? 24.
22.8.
22.8. And that will be kip feet. 22 point what?
8.
Okay. So right now that's the moment and this is the position. Now is it the maximum? I don't know. 1 down, 2 to go. So what's case 2 going to be? well, I'm going to redraw my my system here. Got the same center line, that hasn't changed. I'm going to have reactions at AY and BY, except now what? My load system has changed. So now I'm going to look at balancing the resultant with the second force. You know, the distance between those is 2.67, so I'm going to split that, so that should be 1.33. So that means 1.33 feet to the right, I should have my 1.5 kip load, and 1.33 feet to the left. Balanced is the resultant. Everybody else is at their position. So I know from the resultant forward is the 2 kip force. And that value was 5.3. And then from the 1.5 back to the 1 kip force is 4 feet. And where is the point that I'm looking for? Under this force. So that's the position that I'm trying to find the moment. So if I cut the structure here, you want to work the left side or the right side? At this point, there's really no advantage. No matter where if I cut this, then I'm going to be looking at this piece with one force and a reaction. If I cut it here, I'm going to be looking at one force and a reaction. So it's a wash. Now the previous one was more clear cut. When I cut it here, no forces in a reaction. I cut it here, 2 forces in a reaction. That was easy to see. So what are you guys going to do, left or right? You make the call. Left. So that means we're going to need AY. So we're going to do the same thing as before. We're going to sum moments at B and make sure in equilibrium. Again, I'm going to use the resultant as the system. So about B, the 4.5 is going to create positive moment. And what's the distance from B to there? Well, from here to the center line is 15 feet. Plus 1.33 will be 16.33 feet. And then I'll have my reaction at A, which creates negative moment. And that has a distance of 30 feet. So what's AY equal to? 2.45? Okay. So now we're going to cut the structure. Did you say you want? Yeah, that's right. So there's our moment that we're trying to find. We have our reaction, which we just found, which is 2.45 kips. And we have the 2 kip force. I'll go ahead and just dot down the center line to give you a reference point of where we are. So this little piece here is 1.33, and another 1.33, and then 5. So the distance from here to here is what? 8 feet. Right? We're cutting it here. The distance from here to there, if you add all that up, is 8 feet. So this should be 8 feet. And the total distance is what? Well, from here to here it's 15. That's the center line. Plus 1.33. So underneath this will be 16.33 feet. So I have all the moment arms I need. When I sum my moments here, I'll have 2 kips times 8 feet and the 2.45 times 16.33. So let's do that. We'll sum moments again. at the cut equal to 0. What do we have? We have the internal moment m, which is positive. The 2 kip creates positive moment. 2 kips times a distance of 8 feet. And then the reaction creates negative moment, 2.45 kips times 16.33 feet. So what's the moment equal to? I say 28. I'm guessing.
Yeah, 24.
24?
Yes.
Exactly?
Yeah. Yes.
Oh, that's freaky.
24.00.
24. So comparing the two cases, which one is bigger? Well, we had 22.8, and now we have 24. So right now, case 2 seems to be in control. But we have one more to check, right? So I'll put a fresh sheet down, and we'll do case 3.
Can you raise that up so you can see the bottom? The other one? There you go.
Like that? I can try. Hang on a second. I'm having a little bit of resistance here. You want something like that?
Yes, sir.
Hang on a second. I have a support in the way. There. How about that? Oh, unfortunately, I'll have my hand on it. Maybe I should have moved it up. Are you still writing that down?
No, I'm done now.
Okay. Okay, so we'll come over here, and where should I start? I'll start here. So here is the beam again. We've got our center line. And of course we're going to have our reactions. AY and BY. So now we're going to balance the 1 kip force. Oops, you can't see it. We're going to balance the 1 kip force with the resultant force. So what's the distance between that and that? Well, I think here's an easy way to see it. So the distance between the resultant and the 1 kip force is this, which is what? 6.67. So half of that would be 3.33, right?
Yes. Yeah.
So that means, see if I can do this right. It's going to be a little messy.
Yeah, one's really close to
Yeah.
the line.
Let's see how I can do this and make it work out.
0.66 feet off the center line. 1.5.
Yeah. So what's going to happen is there's going to be the 1.5 is going to be right here. And then the 1 is going to be here. The resultant is going to be here. And then the 2 is going to be up front. So the distance here and here, those are the same. And those should be 3.33 each, right? Now you can see the distance between here and here is 4 feet, so that means that that little distance in there is going to be 0.67 feet. I don't know if we'll need this other one, but we'll check in a second. So now we're looking under the 1 kip, so this is where we're going to make the cut, and that's where I'm going to want my moment right there. So, do I want to cut and look at the right side or cut and look at the left side? I think the left side is definitely way more work. So we're going to cut and go right. And then all I'll need is the reaction at BY. So now I will sum moments at A and make sure this structure is in equilibrium. And again, I'll just use the resultant force. So what's the distance from A to the resultant force. Well, the distance from A to the center line is 15, and then I back off 3.33. So that should be what, 11.67? So about A, this is going to create a negative moment, 4.5 kips times 11.67 feet.
Are we solving for the reaction at B?
We're summing moments at A to find the reaction at B.
Okay.
So the 4.5 is creating negative moment with this distance. And then, so BY will create positive moment with a distance of 30 feet. So what's BY equal to? $1.85. I have no idea. 1.7 what? 1.75? Oh, that's not feet, that's kips. So that means now I'm going to cut the structure to the right. I know what my BY reaction is. It's 1.75 kips. And I want to find the moment here. So what's this distance? Well, again, from BY to the center line is half, or 15 feet, and then I come back off 3.33. That should be 11.67 feet. And to find the moment, then, I'm just going to sum moments at the cut. So with right-hand rule, this moment is negative. And about the cut, the reaction creates positive moment. And the force is 1.75 kips. And the moment arm is 11.67 feet. So it looks like the moment is equal to that.
20.4.
Say again?
20.4.
20.4. So that's 20.4 kip feet.
Case 2 controls.
Yeah, so now you go back and you look at what we've done previously. So case 1 was 22.8, case 2 was 24, so case 2 is the max. So the final answer would be the maximum moment is going to be 24 kip feet, and you can say at what position? Well, at this position. So that would be from A, it would be 15 feet plus 1.33, or at 16.33 feet from A. So you have magnitude and location. Any questions about? Yeah.
As far as the test goes, which type of problem would this be?
That would be none of these.
Okay, so this is not a test.
It could be in the influence line, but that's not an influence line, is it? No. It's none of these.
So, this is like a final question, or?
Maybe. We could talk about it, and you will have worked some homework problems, right? Does that make it fair game? Nudge, nudge, wink, wink. Any other questions? Before we work some other problems.
Can we do an influence